Artificial Intelligence, Project Cycle and Ethical Frameworks. Overview. Learning objectives. By the end of this unit, you will be able to understand the AI project cycle and its stages and learn the importance of problem scoping in AI. Understand about the domains of AI. Set goals using real-world problems and SDGs. Identify and analyze stakeholders involved in an AI solution. Explain the 4Ws problem canvas to scope a problem. Understand ethics and how it relates to artificial intelligence. Compare the differences between traditional programming and artificial intelligence development. Understand 7 characteristics of good artificial intelligence. Understand the ethical artificial intelligence framework. Understand the economic aspects of artificial intelligence. Artificial Intelligence Project Cycle Framework. Before learning about the AI project cycle, let's quickly look at how traditional software is made. This process is called the software development life cycle. What is SDLC? SDLC has the following main steps. Requirement analysis. Understand what is needed. System design. Make flowcharts to show how the system will work. Implementation. Write the actual programs. Testing. Check if the program works correctly. Deployment. Launch the program for users to use. AI project cycle. Just like SDLC, the AI project cycle is used to build solutions using artificial intelligence. It helps in solving real-life problems by following a step-by-step method. Here are the main stages of the AI project cycle. Problem scoping. Data acquisition. Data exploration. Modeling. Evaluation. Problem scoping. First, we select a real-world problem that we want to solve using AI. This step includes thinking clearly about what the problem is and how AI can help. If we can't find a problem easily, we can look at the United Nations Sustainable Development Goals for inspiration. These are 17 global goals to improve the world by 2030. Data acquisition. This means collecting data for the project. The data can be in any form: text, numbers, images, videos, or sounds. Good data is important because AI systems learn from it. Data exploration. After collecting the data, we need to analyze and understand it. This step helps us see patterns or trends in the data using tools like graphs and charts. Modeling. In this step, we choose the best algorithm to solve the problem. The algorithm is used to create a model that can understand and learn from data. Evaluation. This step is for testing the model to check if it works well. If the model doesn't give good results, we can change the data or the algorithm. Once everything is working well, the model is deployed so it can be used in the real world. Domains of artificial intelligence. Data. Natural language processing. Computer vision. Data. Developing algorithms that allow computers to learn from data, identify patterns, and make predictions or decisions without explicit programming. Deep learning. A subfield of machine learning that uses artificial neural networks with multiple layers to analyze data. Reinforcement learning. A type of machine learning where an artificial intelligence agent learns to make decisions through trial and error, receiving rewards or penalties for its actions. Natural language processing. This focuses on enabling computers to understand, interpret, and generate human language. Speech recognition. Allows computers to understand spoken language. Text analysis. Involves analyzing and extracting meaning from text data. Computer vision. This domain aims to equip computers with the ability to see and interpret images and videos similar to how humans do. Object detection. Identifying and locating objects within images or videos. Image recognition. Recognizing and classifying objects or patterns in images. Iterative nature of problem scoping. In an AI project, the problem scoping phase is very important. If it is not done properly, the whole project can fail. The iterative process is a method used in problem scoping to keep improving an AI model. It means creating a basic version, testing it, and then repeating the steps until the final model is ready. Benefits of the iterative process. Each time you repeat the steps, you can fix problems found earlier. It saves money because you find problems early and keep checking the project. It's easier to test and fix small parts at the beginning. You can show progress to clients and others after each step. AI ethics practiced while designing AI projects. When creating an AI model, it's important to follow some ethical rules. The model should be easy to understand for everyone. Everything about the model should be clear and easy to explain. The model should include and be fair to all groups of people. Check and confirm that all assumptions and results are correct. Keep checking how the system is working because problems can happen, and it's important to find them early. Decide who is responsible for the system and who will fix any issues. Setting goals for an AI project. Problem scoping means choosing a problem that we want to solve using AI. Finding a problem and thinking of a way to solve it is called problem scoping. Let's try to find a problem. If you look around, you'll see many problems, some big, some small. Sometimes, we don't notice them because we are so used to them. Choose a topic that interests you the most from the diagram. You can pick any one topic from the diagram. You can also choose from the 17 Sustainable Development Goals. Example: in highway construction, there are many issues like buying land, land quality, cutting trees, giving money to landowners, building roads, raw materials, toll collection, etc. These are all different issues, but they are part of the same work: highway construction. In problem scoping, we pick one issue and try to understand it better. Some more examples. Theme: vaccination drive. Making vaccines, ordering them, sending them to places, finding vaccination centers, online registration, giving appointments, giving different types of vaccines, etc. Theme: promotion to senior school. Finding subject-wise vacancies, dividing students in classes, promoting current students, advertising for new students, managing hostel space, new admissions, assigning classes, making IDs, collecting fees, giving uniforms and books, etc. Theme: budget allocation. Predicting tax income, creating plans to grow trade and taxes, building infrastructure, supporting banks to improve trade, growing the economy, managing jobs. Identifying the stakeholders. After setting the goal, we need to figure out who will be affected by the AI system when it is created. Some people or departments in a company that may be affected by AI are: HR department. AI will make the HR department's job easier by automatically filtering out irrelevant resumes. However, some jobs may be lost because AI can automate tasks, meaning fewer people may be needed. Management. AI can help the company save money by reducing the number of employees needed to complete tasks. IT department. AI needs a lot of data to work well, so experienced workers are needed to collect this data. The IT department will also need more employees to build and maintain the AI system, as well as extra storage space for all the data. 4 W's Problem Canvas. The 4Ws Problem Canvas is a method used to understand how to scope a problem step by step. It helps in identifying 4 important factors that are necessary for solving a problem. These 4 factors are who, what, where, and why. Who? In the Who section, we look at the people who are directly or indirectly affected by the problem. These people are called stakeholders. Stakeholders are those who face the problem and will benefit from the solution. What? In the What section, we focus on understanding what the actual problem is. This is where we identify the nature of the problem. We also need to figure out how we know it's a problem, and we can support this with evidence from newspapers, government reports, or other sources. Where? Once we know the problem and who is affected, the next step is to understand the context and location of the problem. The Where block helps us find out the situation in which the problem occurs and the places where it is most noticeable. Why? Finally, in the Why section, we think about why solving the problem is important. After understanding who is affected, the nature of the problem, and where it happens, we can focus on the benefits of solving the problem for the stakeholders and society as a whole. The Why section helps us understand the positive impact the solution will have. Problem Statement Template. After filling in the 4Ws problem canvas, we now need to write all the important points in one place using the problem statement template. This helps us remember the key ideas easily in the future. Data acquisition. Data acquisition means collecting raw facts, numbers, or information from the right sources. This data is used for studying or for building AI projects. In the AI project cycle, data acquisition is the second step. It takes a lot of time because different types of data are found in many places, and we have to collect only the data that matches our project needs. What is data? Data is raw information, like facts or numbers. It needs to be processed to become useful. In AI projects, we need data to train the system so it can make predictions. Data is the base of any AI project. There are two main types of data. Training data. This is the data used to teach the AI model. The correct answers are already included in it. Testing data. This is new data used to check how well the AI model works. The model hasn't seen this data before. Example, if we want to build an AI model to predict the average marks of students, we will give it marks from past years. Then, we will test the model using new marks to see if it gives correct predictions. Data features. When we collect data for an AI project, we need to make sure it is useful. We should think about what factors affect the problem. Data features are the different parts of the data we want to collect. Example, subject-wise average, number of students, theory and practical marks. Reliable sources of relevant data. Good data must come from trustworthy sources to make the AI project accurate. Some reliable sources include surveys, collecting answers from people using forms or questions. Web scraping, collecting information from websites. Sensors, devices that collect real-time data like temperature or pollution. Cameras, collecting data as images or videos. Observations, watching and recording events as they happen. Application programming interface, tools that help one software collect data from another. Note, we should never use private or fake data. It's best to use data from official government websites like data.gov.in or india.gov.in because they are safe and reliable. System maps. A system map is a diagram that shows how different things work together. It shows the parts of a system and its limits. System maps help us understand how different parts of a problem are connected. They help us find ways to reach the goal of our project. Let's look at an example. Streets are safer for people to walk when fewer people are driving. When the number of vehicles increases, pollution also increases. We use system maps to understand difficult problems where many things affect each other. A system has elements, different parts in the system. Interconnections, how the parts are connected to each other. Rules for system maps. Circles show elements. Arrows show connections between elements. The plus and minus signs show the type of relationship. If an arrow goes from x to y with a plus, it means that when x increases, y also increases. If an arrow goes from x to y with a minus, it means that when x increases, y decreases. After we collect the correct data, the next step is data exploration. This means finding patterns or trends in the data. It is the third step in the artificial intelligence project cycle and the first step in data analysis. It helps us understand what the data shows and what kind of data we have. Data exploration cleans big data to use it in an artificial intelligence project. Huge amounts of unused data are not useful. But when we process it properly, it becomes very valuable. Data visualization. Data visualization is the way we show data and information using pictures, like charts and graphs. It makes it easier to see trends and patterns in the data. We can do data visualization using both automated tools and manual methods. It helps to organize scattered data into a clear pattern and helps us see important trends. It also helps us make better decisions. Why do we need to explore and visualize data before using it in an artificial intelligence model? Understand trends. Visualizing data with graphs grabs our attention and makes it easier to see patterns. Numbers alone can be hard to understand, but a chart helps us see trends quickly. Deciding which model. Humans understand visuals better than tables of data. Data visualization tools help us make decisions faster, which helps businesses grow. Easier to comprehend. Visualization helps us understand large amounts of data that would be hard to read in rows. A good visualization tool helps clean up the data and highlight important information. Easier to communicate. Visualization helps us share lots of data with others in a simple way. Interactive tools make it easy to explain findings and important information to others. Why is data visualization needed? It simplifies complex information. It helps us analyze and explore big data easily. It helps find areas that need improvement. It shows the relationship between different data points. It reveals new and hidden patterns in the data. Data visualization tools. There are tools for both manual and automated analysis to help us visualize and understand the relationships between different sets of data. Here are some commonly used tools. Microsoft Excel. This is a tool from Microsoft for manually exploring data. It can create basic charts and graphs to visualize small data sets. But it's not good for very large data. Tableau Public. This free software helps create interactive data visualizations that can be shared with others. It works well with large datasets and is very popular for data visualization. Microsoft Power Business Intelligence. This tool, provided by Microsoft, helps visualize data and is free to download and use. Data Wrapper. This tool is often used in the media industry. It uses comma-separated values files to create charts and maps. Google Data Studio. Part of the Google marketing platform, this tool helps create different views of your data. Other websites also offer data visualization tools, like this website provides various types of graphs and flowcharts for data visualization. What is modeling? Modeling. Modeling or data modeling is the process of creating a decision-making system. This system learns from the data collected earlier and uses that learning to find patterns. After making graphs and understanding trends from the data, the next step is to build an artificial intelligence model using algorithms. We can create our model or use one that already exists. Before learning more about modeling, let's understand some important terms. Artificial intelligence. Artificial intelligence is a technology that helps machines act like humans. These machines can do tasks on their own once they are programmed. Artificial intelligence allows computers to think and work without needing human help. Machine learning. Machine learning is a part of artificial intelligence. It helps machines learn from their past experiences. Machines use data to improve their performance over time. Examples: Snapchat filters, Netflix movie suggestions. Deep learning. Deep learning is a part of machine learning. It uses a large amount of data to help machines learn better. It works like the human brain, using special units called neurons. Examples: Google Translate, face detection in social media apps. Artificial intelligence is an umbrella term that holds machine learning and deep learning. Deep learning follows a specific learning approach, which is a subset of machine learning, comprising multiple machine learning algorithms. Difference between artificial intelligence, machine learning, and deep learning. Artificial intelligence. AI aims at making a machine that mimics human intelligence. It is a subset of data science. It is the simulation of in machines. Machine learning aims at making a machine that can learn through data and solve complex problems. It is a subset of AI. It is the training of machines to take decisions with experience. Deep learning aims at building neural network that can help in discovering patterns or trends. It is a subset of machine learning. It is the process of using artificial neural networks for solving complex problems. Data modeling techniques. In artificial intelligence, we create algorithms that help machines give smart results. This means we write code that makes machines act intelligently. There are two main ways to build these models: rule-based approach, learning-based approach. Rule-based approach. In this method, the machine is given a set of rules and facts. The developer tells the machine how to use the data. This method works with simple and clear data. Example: You have 100 pictures of cars and 100 pictures of cycles. You tell the machine which picture is a car and which is a cycle. Now, if you show a new picture of a car, the machine compares it with the old ones and tells it's a car. This is a rule-based approach because you gave it clear rules. Learning-based approach. Here, the machine is not given any rules by the developer. The data is random and not labeled. The machine finds its own patterns or trends from the data. Example: You have 1000 pictures of flowers, but you don't know their names or features. You give all these pictures to the machine without any labels. The machine studies the pictures and groups them based on things like color, shape, or size. Sometimes, it may even group them in ways we didn't think of. Decision tree rule-based approach. A decision tree is a tool used to make decisions by following a flowchart-like structure. It starts with one main question at the top and then branches out to different options, leading to final decisions at the bottom. This method is often used in supervised learning, where the goal is to predict an outcome based on given conditions. In a decision tree, root node, the first question or condition that represents all the data. Branch, the path that connects nodes, showing different possible outcomes. Decision node, a point where the tree splits further based on a condition. Leaf node, the final decision, where no further splitting happens. Parent node, a node that is above another node. Child node, a node that is below another node. Some of the important points to consider while designing a decision tree. There can be multiple decision trees for one dataset, but the simplest one should be chosen. Not all data is useful, only the factors that affect the result should be included. Look at the patterns in the data to help create the tree and find the links between similar outcomes. This approach helps in making clear and logical decisions based on available data. Pixel-it, learning-based approach. Pixel-it is a method used in computer vision, where computers learn to understand and classify images. Images on a computer are made up of tiny pieces called pixels. This approach helps the computer recognize and read images by analyzing these pixels. AI project evaluation. Evaluation is the final step in an AI project. It checks how well the AI model works, including its efficiency and accuracy. This step helps improve the model to reach the project goals. To make this happen, certain hardware and software settings need to be adjusted, so the artificial intelligence model can be used effectively by the end users. Artificial Intelligence Project Deployment. Deployment is the process of using the artificial intelligence model in the real world. It means integrating the model into an existing system so it can work with actual data and provide the desired results. To make this happen, certain hardware and software settings need to be adjusted so the artificial intelligence model can be used effectively by the end users. Ethics and existing systems. What is ethics? Ethics is defined as the moral principles governing the behavior or actions of an individual or a group. In other words, ethics are the rules that help us determine what is right or what is good. Ethics in artificial intelligence. Fair and responsible use. Ethics in artificial intelligence is about making sure that artificial intelligence systems are used fairly and responsibly. How? However, with the growth of artificial intelligence, there are important questions about how it should be used. For example, artificial intelligence can sometimes make biased decisions, which means it could treat people unfairly based on things like their race, gender, or background. Harm is caused when a prediction or end outcome negatively impacts an individual's ability to establish their rightful personhood or access resources. Another concern is privacy because artificial intelligence often collects large amounts of personal data, and people worry about how this information is used. Artificial intelligence is a new field and is likely to impact humanity in a big way. There are many things to be considered to ensure that it does not harm us in any way or lead to unfair actions. Ethics and existing systems. Ethical principles serve as a guideline to distinguish between wrong and right while making decisions or doing something. For example, I may have the freedom to walk with a stick rotating in my hand, no harm. But I shouldn't do it on a crowded road. Simply, when we put our smartphone on vibration in a hospital or movie hall. Ethical principles. Ethical principles serve as a guideline to distinguish between wrong and right while making decisions or doing something. Artificial intelligence is fast in nature, vast in scale and impactful on industries and society. So, like anything fast, vast and powerful, it has the potential to cause benefit and harm as well. When artificial intelligence's outcome or predictions will cause benefit, it is good artificial intelligence, and if harm, then it is unethical artificial intelligence. Artificial intelligence is being developed by humans to impact humans finally. It is for them to make ethical considerations related to the capability of artificial intelligence and its impact on society and the environment up to some extent. Traditional programming versus artificial intelligence development. Algorithm approach. Traditional programming is based on a finalized algorithm that remains fixed for one or more versions of the program. In contrast, artificial intelligence development involves dynamic algorithms that are designed to learn and adapt from data. Data usage. While traditional programming requires data to be processed to achieve a desired output, artificial intelligence development uses data for two primary purposes: training the machine and analyzing results. Process flow. The basic approach in traditional programming is linear, following the input-process-output model. On the other hand, artificial intelligence development follows a cyclic approach that involves input, training, analysis, prediction, and continuous improvement. Data structure. Data used in traditional programming is mostly structured and well classified. However, artificial intelligence systems rely on unstructured data with numerous variables that are essential for effective training. Data handling. Traditional programming typically works with complete data entities like numbers, text, or images. Artificial intelligence systems, however, can analyze partial data, such as identifying a face within a group photograph. Application purpose. Traditional programming is primarily used to develop automation and productivity applications. Artificial intelligence development, on the other hand, aims to enhance efficiency and intelligence in both existing and future systems. Skill requirements. While traditional programming requires fundamental computing knowledge without the need for advanced programming skills, Artificial intelligence development necessitates a strong understanding of programming, database systems, and related technologies. Field of application. The field of traditional programming revolves around computer science and application development. In contrast, artificial intelligence development integrates various fields, including computer science, data science, statistics, mathematics, research, and business intelligence. Development models. Traditional software development often follows models like waterfall, spiral, or agile. Artificial intelligence development, however, has the potential to enhance these models by making them smarter and more adaptive. Data management. Finally, traditional programming is suited for processing limited data sizes, often handled in batches. On the other hand, artificial intelligence systems excel at managing large volumes of dynamically changing data, often referred to as big data. The good artificial intelligence. Artificial intelligence is a type of smart technology that can perform tasks that usually need human thinking. It can help us in many ways, but it is important to ensure artificial intelligence follows ethical rules. Ethics means doing what is right and fair. When artificial intelligence is made, it should follow these rules to benefit people and society. Good artificial intelligence systems have several key characteristics that make them effective, reliable, and valuable. For example, voice assistants like Siri or Alexa should only listen when you say their wake-up word. They should not listen to everything you say without permission. This keeps your privacy safe. How artificial intelligence can help us ethically. Making the best use of technology. Over many years, a lot of data has been collected. Computers are now very fast and can analyze this data using artificial intelligence. Artificial intelligence can find hidden information in this data, helping industries, businesses, and governments make better decisions. It can predict weather, track diseases, and find better ways to grow crops. Enhancing human potential. Artificial intelligence can do repetitive tasks quickly, allowing humans to focus on more creative and important work. It is used in factories, hospitals, and offices to reduce human effort and increase productivity. Addressing the previously non-addressable. Artificial intelligence can study large amounts of data to find solutions to serious issues like poverty, lack of education, and diseases. It can also help in protecting the environment by controlling pollution and fighting climate change. Enriching human life. Artificial intelligence-powered smart homes and smart cities can improve safety and comfort. Artificial intelligence helps doctors diagnose diseases quickly and suggest better treatments. It also helps in the fair distribution of resources like water, electricity, and food. Working towards equity. Artificial intelligence can reduce the gap between rich and poor by improving access to education, healthcare, and job opportunities. It ensures that everyone gets equal chances to grow and succeed. Artificial intelligence systems can make valuable resources available to underserved communities. Easing conflicts and promoting harmony. Artificial intelligence can help countries solve disputes by analyzing data and providing better solutions. Leaders can use artificial intelligence to make fair and informed decisions. Data-driven insights help minimize conflicts between groups. Artificial intelligence facilitates international collaboration on shared challenges. Giving back to Mother Earth. Artificial intelligence can predict natural disasters, like floods and earthquakes, helping people stay safe. It monitors pollution levels and suggests eco-friendly solutions. Artificial intelligence supports farmers by advising them on the best time to plant and harvest crops. Ethical challenges with artificial intelligence. Artificial intelligence is a powerful technology that can help humans in many ways. However, we must be careful about how we use it. Artificial intelligence needs to be used responsibly, following ethical rules. Ethics means doing what is right and fair. There are some big questions we need to think about. How can we make sure artificial intelligence is used in a good way? What problems can artificial intelligence create? Who will be responsible if artificial intelligence makes a mistake? Accountability. Accountability means knowing who is responsible if something goes wrong. If a self-driving car hits someone on a foggy morning, who is to blame? Is it the car's owner, the car manufacturer, the artificial intelligence developer, or the person who was hit? We need clear rules and laws to decide who should take responsibility in situations like these. Transparency and bias. Transparency means understanding how artificial intelligence makes decisions. Bias means unfairness. Artificial intelligence learns from data. If the data it learns from has unfairness in it, artificial intelligence can also become unfair. If an artificial intelligence system selects people for a job interview, but learns from biased data, it might reject qualified people unfairly. Developers must check artificial intelligence data carefully to avoid this problem. Types of bias. Pre-existing bias. Biases that already exist in society can show up in artificial intelligence systems. For example, if reports from certain communities are ignored, artificial intelligence may treat those communities unfairly. Technical bias. Sometimes artificial intelligence systems have technical problems. If a booking system slows down when many people from a particular area apply, it is unfair. Also, artificial intelligence might fail to recognize certain objects if it is not trained with enough data. Emergent bias. Bias can appear when people start using artificial intelligence. For example, an online appointment system may be difficult for older people or those with disabilities to use. To fix bias, artificial intelligence needs to be tested carefully using large, diverse datasets. The data must represent everyone fairly. Security and privacy. Security means keeping systems safe, and privacy means protecting personal information. Artificial intelligence can become dangerous if it learns how to hack systems or misuse data. Artificial intelligence connected to Internet of Things devices, like smart home systems, needs extra care. Faults in artificial intelligence systems can cause false alarms and lockouts or block important services like ambulances. Cyberbullying, data theft, and hacking are real risks. Developers must create strong cybersecurity measures to prevent these problems. Privacy issues. Artificial intelligence often collects data to learn and improve. However, collecting too much personal information can be harmful. Artificial intelligence systems used for surveillance or data gathering can breach people's privacy. Copyright issues can arise if artificial intelligence writes books or articles by copying from other sources. Developers must balance the need for data collection with protecting people's privacy and rights. Decision-making and human values. Artificial intelligence can make decisions based on data, but it may lack human common sense and values. Artificial intelligence decisions can sometimes be unfair or harmful. For example, if the government uses artificial intelligence to decide policies for drought-prone areas, how can we ensure the artificial intelligence system has considered all viewpoints? Another example is during emergencies. Imagine a sinking ship. One artificial intelligence system may lock doors to stop water from entering, while another system may open doors to let smoke escape. Which one is right? Artificial intelligence needs to learn human values to make balanced decisions. Ethical framework for artificial intelligence development. Forums like Artificial Intelligence for People and organizations, such as the Institute of Electrical and Electronics Engineers, have established guidelines to ensure artificial intelligence development benefits society while adhering to ethical standards. An ethical artificial intelligence design should follow these principles. Human rights. Artificial intelligence systems must respect and protect human rights. Well-being. Artificial intelligence developers must prioritize human well-being. Data rights. People must have control over their personal data, ensuring privacy. Effectiveness. Artificial intelligence should be reliable and resistant to hacking and crashes. Transparency. Artificial intelligence processes should be clear and understandable. Accountability. Rational guidelines must govern artificial intelligence decision-making. Awareness of misuse. Measures should prevent artificial intelligence from being misused. Competence. Artificial intelligence developers should have the necessary knowledge and skills. These principles ensure artificial intelligence systems are used responsibly for the greater good. Policy framework for good artificial intelligence. Policy framework for good AI. Governments worldwide are establishing artificial intelligence policies to maximize benefits and reduce risks. Some key points for effective artificial intelligence policies include: update human rights policies to ensure privacy and freedom. Align AI development with national economic growth, focus on GDP enhancement. Develop policies that protect data privacy and grant users control over their information. Establish testing systems to evaluate artificial intelligence's performance and security. Ensure artificial intelligence transparency for easier fault detection and correction. Implement laws for artificial intelligence accountability, especially in cases of malfunction. Determine clear guidelines for artificial intelligence system stakeholders. Minimize system misuse by educating users about artificial intelligence risks and responsibilities. Develop guidelines for responsible artificial intelligence use, ensuring safety in the event of malfunctions. The economics of artificial intelligence. Artificial intelligence uses smart computer programs that can learn and make decisions. But for artificial intelligence to work well, it needs special tools, advanced software, and powerful computers. It also needs a lot of data to learn from. Because of this, companies spend a lot of money on artificial intelligence systems. However, if artificial intelligence helps the company earn more money or work faster, then the investment is worth it. Using artificial intelligence platforms. Cloud platforms. Big companies like Google, Amazon, and Microsoft provide artificial intelligence services through cloud platforms. Tools and support. These platforms offer tools, storage space, and technical support for businesses. Time and cost savings. Instead of creating artificial intelligence from scratch, companies can use these ready-made services to save time and money. Customizing artificial intelligence for businesses. Some companies prefer to modify artificial intelligence to fit their needs. This process is called customization. It is often cheaper than building a new artificial intelligence system from the ground up. Companies do not have to change their entire technology. They can simply add artificial intelligence to their existing systems. For example, a bank can use an artificial intelligence chatbot to answer customer questions online. The chatbot gives quick and accurate responses without human help. The bank's main system remains the same, but artificial intelligence helps save time and reduce costs. Affordable artificial intelligence solutions. There are also budget-friendly artificial intelligence options, such as voice assistants like Alexa and Siri. These assistants use natural language processing to understand what people say and respond correctly. Many companies use similar artificial intelligence tools for customer service, making them cost-effective.